Hello everyone. In this lecture, we will learn about avoiding common drone survey mistakes. Drone surveying is a powerful technology, but like any technical process, mistakes can happen, especially when pilots are new to mapping workflows. Even small errors during planning or flight can affect the quality, accuracy, and usability of the final survey data. In this lecture, we'll explore some of the most common drone surveying mistakes and how you can avoid them to ensure professional results. First, flying without proper mission planning. One of the most common mistakes is launching a drone without carefully planning the mission. Without a clear flight plan, the drone may miss important sections of the survey area, resulting in gaps in the data. Poor planning can also lead to incorrect altitude settings or insufficient image overlap. Always create a detailed flight plan using mapping software before starting a survey mission. Second, using incorrect image overlap settings. Image overlap is essential for photogrammetry. If the overlap between images is too low, the mapping software may not be able to properly connect the images. This can result in an incomplete maps, distorted models, or failed processing. As a general guideline, most mapping missions use around 70 to 80% front overlap and 60 to 70% side overlap. These settings ensure that each area is captured from multiple angles. Third, flying too high or too low. Incorrect flight altitude can significantly impact the survey results. Flying too high may reduce the level of detail in the images, while flying too low may require too many images and increase processing time. The key is selecting the right altitude to achieve the desired ground resolution while maintaining efficient coverage. Fourth, ignoring weather conditions. Weather is another major factor in drone surveying. Strong winds can make the drone unstable, causing blurry images or uneven flight paths. Rain or fog can also interfere with sensors and reduce visibility. Professional drone operators always check the weather forecast and avoid flying in unfavorable conditions. Fifth, not using ground control points when needed. For projects that require high accuracy, relying only on the drone's onboard GPS may not be sufficient. Failing to use ground control points when needed can lead to positional errors in the final map. Strategically placed GCPs helps improve accuracy and ensure that the drone data aligns correctly with real-world coordinates. Sixth, forgetting the check equipment before flight. Skipping pre-flight checks is another common mistake. Low batteries, damaged propellers, or dirty camera lenses can affect flight safety and image quality. Always follow a pre-flight checklist to ensure the drone and equipment are ready for the mission. Seventh, poor data management after the flight. After completing the mission, it's important to verify that all images were captured successfully and stored correctly. Losing or corrupting image data can make the entire survey unusable. Always back up your files and organize your data before starting the processing stage. Here are the key takeaways from this lecture. Feel free to pause the video and have a look. Avoiding these common mistakes can greatly improve the quality, reliability, and efficiency of your drone surveying workflows. By combining careful planning, proper flight settings, and thorough preparation, you can ensure that your survey missions produce accurate and professional results. In the next lecture, we'll discuss another important factors that affects drone surveys, the best weather conditions for drone mapping, and how weather impacts aerial data collection. Thank you.